I am a four-sided shape. I'm a four-sided shape. And I have a perimeter of 3 metres. What might I look like? No answers? Not interested. Let's establish something for a start. What's perimeter? Amanda, what's perimeter?
Measure around the outside or something?
Touch some.
Sorry.
Touch some. I love that you went straight for the table. Perfect. I was hoping you would. I would have given you some direction to do that, but you went straight for it. So, and I'd normally get you up and around to do the whole thing around the table. Jess come showing the perimeter of the whiteboard, and you'd come out and I said, yep, it's the outside stuff. All right, so we've established that. So let's put in the key words. So perimeter, boundary, it's like a fence. It's around the outside. All right, so I'm a four-sided shape over a perimeter of 3 metres. What might I look like? Some of you are already going, huh? Well, okay. In the end, you're all going to draw a diagram because you'll be presenting your work, and there'll be more than one shape, by the way. You'll all be doing a schmancy diagram. It'll be schmancy. It won't be just ordinary, it'll be schmancy. You'll be doing a schmancy diagram, but you might just do a rough one to get you started. You might go, oh, yeah, right, like that side can be 1 metre, so that'd be what, yeah, that sort of thing. So that's draw a diagram. Yeah, you could, as always, kids, guess and check's up for grabs. So you might see a shape and go, okay, what if that was 2 metres, then that would be, oh, no, that's not going to work. So I'm already 4 metres. Oh man, I'm going to make that. Yeah, that's guessing and checking. It's cool. You might already see this as like make a table. Where basically, if you are, I guess you're on the right track. Like you might go, okay, that's S1, side 1, side 2, side 3, side 4, and total perimeter. And you go, okay, this has got to get to 3 metres, so I'm going to make this. I'm going to make this 2 metres, so I'm going to make this 0.5, and I'm going to make this blah, 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 or I'm going to make this 1 metre, that side's going to be 0.5, that's, yep, 3 metres, so you're filling that in. You'll have to turn some of the maths here into physically a diagram, but that might be a way to get started. You might want to make a model, so I've got some bendy straws over there. And some pop sticks as well, so you might go, okay, if I bend that like that and I do that, oh yeah, so you might want to physically touch it first to make it. You might want to write an equation, and you might even want to use the formula, which is a bit of algebra. You bet it is. P equals 2L plus 2W. Bit of 2L plus 2W. What's the W? What's the W? Width, which just comes from the word wide, by the way. It's just a goosey way to say wide. Width. It comes from the word wide. So width that way. What's the bit? Length. So we got 2 lots of long, 2 lots of length, and you got 2 lots of wide. So you might just do it as an equation. You go, oh, yeah, man, I can do 2 lots of this, plus whack it in a bracket, plus 2 lots of this, whack it in a bracket, make sure that equals 3. Solve a simpler problem. What's an easy way? Because some of you already, if you're not already thinking it, the 3 is pushing you into decimals. If you didn't realise it, oh, yes, I am. I'm pushing you into decimals. There is an alternative, though. What's another way to think of 3 metres? 300 centimetres. Now all of a sudden, oh, who can't add to 300? No, of course you can. So if you want to solve a problem, it's an easier problem, think about it as 300 centimetres. I just might put that in their key words. That's CM and metres is M. All right, well, what do you got? 1, 2, 3, 4, 5. You got six, and look, even there's always work backwards. Work backwards is always as easy as start with the answer. The answer is 3. In this alternative, we were multiplying. Well, why don't you divide? Your first answer you can work out by going 3 metres, divide that by 4, you've got an answer. You've got your first one done. And now you might go, oh, I can use that info. Yeah. Boys and girls, you got to come up with at least 5 different shapes. Yeah, 5. And only 60% of your shapes can be rectangles. Only 60% of your shapes can be rectangles. Yeah. All right, Kiara, what strategy, you wascally wabbit, are you going to go with? Draw a diagram. So you're all going to present 5 schmancy diagrams at the end, but Kiara's just going to draw some rough ones to get us started. By the way, when you come into your schmancy ones, don't be surprised if I start using the word scale. Yes. All right. What are we using? What strategy?
Guess and check.
Guess and check. What are we using? Table. What are we using? Write an equation. Diagram. What are we using?
Work backwards.
Work backwards. See how your first answer's already generated? What are we using? The table. All right, so I go around the room again, even if the year 7s and 8s, I still chop around the room, get a commitment. So, because when you tell me, basically you're saying, yeah, I'm ready to go, and I've told you I've told you which one I'm using, so I'm now accountable. And that's from preps to year 10. They feel accountable. You feel accountable now because you've told me what you're doing. You don't look like you're accountable because now you're no longer doing anything. But now let's all right, yeah, just have a play with it for 2 or 3 minutes. Put yourself in the place of the kids and see how you go and see how it feels. If your 5-6s have gone through a lot of this sort of work with problem-solving strategies, this is a 5-6 problem. What I get a lot of, though, is that hasn't happened. I present this to 7s and 8s, and they're quite challenged. Then, once they get on the roll, get ready, because they're pretty quick after that, so I'm ready to do... I've got a couple other things on my sleeves with different shapes that they have to prove. How easy would it be? See if it had to be a triangle. That'd be so easy. Be an equilateral triangle, but it isn't. D-man, how you going? Oh yeah, working out a few. Yep. Now in the end, I love this, but you're going to have to turn those into a real shape. So what looks like it works mathematically has got to work when you come to draw it. How you going, Amanda? You all right?
Yeah.
Teagues? Oh, I'm loving that. I'm loving that. My first thing, like I know these are rough, so I've got no problems. Like there's no way knowing if that's 2, that looks as long as that one. Whereas that one's got to be twice as long. And then you've got to make sure you can come back. So then it's up here. Then you can do the 8.5. But then no way known it's going to be 8.5 on the journey back. So later on, the maths works. Just make sure you can do that. Like that it's possible to be drawn.
What strategy am I technically doing?
Draw a diagram, and with a bit of guess and check. But yeah, technically, you're doing rough diagrams to get you started. But isn't it funny? Like, it's just kids. The D-Meister's gone straight for make a table because it's mathematical. He sees them for this problem, but in a different problem, you might be using write an equation. But this one's got you thinking. So Helen's gone has gone for make a table too. Because you're mathematical logical.
And I'm trying to work it out, like trying to draw what it would look like.
Yes, that's the challenge.
Yeah, because sometimes...
See, they mix, they cross over. Yeah. Which is cool. Remember, all you're always doing with these, the strategies are just a foot in the door. They're what gets you started. So you don't just stare at the problem and go, I don't know what to do. So that's the whole point. You actually I've given you strategies to get you started. Ew. Parallelogram, one of those. Make sure you've got plenty of room for key words for this one because you guys are coming up with irregular shapes, parallelograms. I'll end up seeing trapeziums for sure. Who's already tried a trapezium? Yeah. So get those all in your key words. The drawing part, that's why if they've got the gridded maths books, or you've got the isometric, or you've got the dot paper, and you can start talking about scale now. It's really good. What did the 60% restriction mean? How many are allowed to be rectangles? Yeah, I wanted 5. 3 out of 5, 60%, and you've got a nice little fractions, sort of little byplay in there as well. All right, so the table generated the maths.
Yep.
Now, can they literally be drawn?
Yep.
That one, yeah. What shape's that?
This one here.
Yeah, it's got to be a square. Yeah, yeah. So so you're just connecting up things like your fractions and your decimals to shape and. Which is a rectangle. Yeah, the square, when squares goes home at night, square goes round into the rectangle joint, hangs out with the other rectangles, and squares like, yeah.
Special.
Squares on the way home, go, yeah, that's my place, where the rectangles are. Squareo, how you been? Good, Recky? How you been?
Yeah, that's right. That's right.
Wreck. I'm wrecked. That's all right, it's better than being square. Good trapezium there too, Eck. Like it. Jess, how's it going? You've got your trapezium there. Oh, I like how you've tried to schmancy up the maths here. 1.5, 1.3. Actually, that will work. I don't know if that literally looks right, but the maths is right. Where they literally will work. Oh, that's 8.6, which is longer than the side, which is, oh no, that's 0. Not 1.0. All right, I'll be interested to see how that one's going to pan out. So that bottom one has to be 2.2, does it?
No, I gave up. That one's wrong.
All right, okay, that'll do. Good, nice little challenge. Mm-hmm. Right up there in the upper primary, lower secondary range. But they've had a lot of fun with that, a lot of connected maths. It's a great way for linking up areas of maths. You've got decimals, you've got fractions, you've got scale. Absolutely. Like some of your maths is going to be hard to draw. Very hard to draw. Yeah. Because the maths works, and you go, hold on, but it's got to work because the maths works. And again, we'll draw it. And you prove that it can be drawn, and that's when scale comes right into it. So that's just another example. It's an open-ended problem, more than one answer, more than one way to get at the answer. I might finish this one with the kids, especially upper primary and lower secondary. I might finish with this with kids. You've got 20 words to tell me what we found out doing maths today. 20 words exactly. Like when I mean exactly, I mean exactly. Like if you write 22 words, I'll just say, choose me, Kiara, go back and get rid of 2 words. You're 2 words over. Get rid of 2. If you write like 19 words, Linda, I'll go, yeah, good, you owe me a word. And fit that in somewhere because it looks stupid at the end, going and. So the kids go, right, exactly, twist, yes. I said, and full stop is not a word unless you write 18 words and then finish with the 2 words full stop. But don't put a full stop in there then. You can do that. Okay, that's my way of saying yes. Enjoy the task, but I'm not going to be that finicky. But I do, so I also warn them, and make sure you do this too, because you'll get it otherwise. 2 things I warn them about: don't try doing. I really like doing maths today. Said nah. I said was only remotely funny first time. That's definitely not funny now. Don't bother. And then I said the other thing I tell them is. No recounts. I don't want to know what you did. I'll tell you to go and do it again, which is not being that mean, kids, because you've only done 20 words. It's not like you've written War and Peace. So I'll tell you to go and do it again if there's a recount. So don't tell me what you did. It's got to be about what you found out. Oh, I don't know what. Well, yeah, all And I said, you know what? If you start off with today, I found out. That's 4 out of 20. That's simples. Make that simples. That's 2 out of 10. That's 20% converted. So if you write those 4 words, you've already done 20%. And that's normally for the 3 reluctant riders. They go, oh, yeah. Yeah. Oh, yeah, we're on our way. I said, yeah, you are. Get going. And so that's the way you sort of get that going. And all I do after that is, who's got a book ready? You have. Sorry, what's your name?
Penny.
Penny. Sorry, Pen. Second time. Sorry, Pen. So I just picked the first kid out. There's Penny's first one done. I said, bring him out. So Penny brings it out. And I go, right, let's check it. 1, 2, 3, 4, 5. And that's all you have to do. Just do it. Don't do it loud, but do it loud enough that everybody hears. I go, Pen, let's have a look. 1, 2, 3, 4. And then all the rest of you go, oh, gosh, shit, he does count them. Does he count? Yeah, he does. He's counting pennies. Oh, he does count them. And so then after that, you go, every kid's trying to count, make sure they got 20. Some write them in 5 words per line. Some have got a number above every word to let you know. So it's gorgeous. It's actually gorgeous. When did I do that? That was Thursday. Some kids have finished with 18 words and they've gone, thank you. Some kids like, bye, Eric. For the last 2 words, or they're just great, or just thanks, and and have a bit of fun with it. But sometimes those 20 words are like you just read them and go, whoa, it's actually good assessment information, and because kids will let you know that they can or can't, or what they found hard or easy in those 20 words, and they'll let you know how much they enjoyed it too normally, and you just go, man.